So a quick review of solving this equation. We want to solve for x, so to undo that, one option is subtracting 7 from each side. Then, since x is being divided by 2, we can multiply each side of the equation by 2. Therefore, we were undoing that division, and by doing the multiplying by 2, we end up with x being 30. If we double check again by putting 30 back into the expression to make sure it's balanced, we know 30 divided by 2 is 15, and if we have 15 and 7, it gives back our 22. So a quick review of working with an equation, a linear equation, because we have one variable, undoing it to solve for that value of x. And notice how we had a fraction, right? A rational piece to that equation. And remember, rationals are just fractional parts. We look at those basic components to see how we can use that to help simplify what we're working with. Another option, what we could have done is looking them all as rational pieces for our equation. So again, we could make them all look like fractions by putting those constants over 1, and then look to see how to undo each of those. We know when we're fractions and adding them, we have a common denominator, and so if I look at the elements of the denominators, 2, that comes from 1 times 2. 1 is 1 times 1, and same thing here. So we needed a 1 and a 2 to have a common denominator of 2. So if I multiplied each piece of the equation by 2 to undo that, let's see what would happen. And then looking to simplify, any like things we could divide out. 2's here, so we would have x plus 14 equals 44. And it's just solving to get x by itself by subtracting 14, so x equals 30. And again, we could check those by substituting it back in to make sure it's balanced to get back your 22. Let's look at another equation. Here we've got m over 28 equals 3/7. Again, these are two rational pieces, fractions. We want to solve for the value of m that makes this true. So perhaps we could use the second approach that we were using in the first example to see how we could undo it. So because they are fractions, right, we could look at the elements in the denominator and find a common denominator to undo that equation. So here we've got m being divided by 28. We know 28 comes from 4 times 7, so if it's being divided by 28, if I multiplied each side by 28, that would undo that. And we know 7 is also a factor of 28, so by taking care of multiplying by 28, we're also doing that, undoing the division of 7. So by multiplying by that common denominator of 28, let's see what happens. Again, 28 will divide out, 7 will divide out, so we're left with m equals 4 times 3, which is 12. Again, to double check and make sure that's the correct value, substitute it back into the original equation to see that it's balanced. So 12/28 is that the same as 3/7. Well, we know here there's a common factor of 4 that we could divide out, so we're going to have 3/7 equal to 3/7, which we know it's balanced. So let's look at solving another rational equation. We've got 2 over x equals 10 over x minus 6. Let's see if we can think about some of the other items we've done in the previous problems to help us solve this one. Fractions are just another way of thinking about division. So let's think about our denominators. Here we've got x and x minus 6. Both of those are on their basic components. They're already factored. Well, if we're dividing by x, we'd have to undo that by multiplying by x. And if we were dividing by x minus 6, to undo that we have to multiply by x minus 6. So the common denominator to undo those two divisions would be x and x minus 6. We'll multiply the entire equation by both of those pieces to undo the divisions. So you can think about when we're multiplying, right? We multiply numerators and denominators. So let's see what we have. So 2 times x minus 6 over x, and then 10 times x minus 6 over x minus 6. So we've done the multiplying. Again, we're looking to see what we can simplify like terms from numerator and denominator to divide out. So this left-hand side, both of them have an x. We could divide that out, so we'd be left with 2 times x minus 6 on the left. On the right, they both have an x minus 6. I could divide that out and be left with x times 10. We know 2 times x minus 6 is 2x minus 12, and x times 10 is just 10x. Now we just have a basic linear equation that we can solve. So we're going to subtract 2x from each side, then divide by 8, and try to always put your answer in the simplest form. So we've got negative 12/8. We know that 4 is a common factor for each of those numbers. Divide out of 4 from each, so we'd have a negative 3/2. Again, to double check that this is truly the correct value, we could substitute it back into the original equation and make sure that it's balanced. And we're good to go. We found the value for x that makes the equation true. It's very important that we're substituting it back into the equation. 1, make sure that you've algebraically solved it correctly, and 2, we're not running any problems, especially because they're fractions with denominators. We know that a denominator has to be a number other than 0 for it to work, otherwise it would be undefined. So if I ended up with a value for x that would give me a denominator worth 0, that would end up being no solution, because I cannot use it to give me a valid response. It has to be defined in order to work. Here's another problem. And again, we want to solve to find what value of x makes this true. So because we've got our fractions, look at your denominators. Are they in simplest forms? Can you factor them any more than they already are? X plus 5 is as basic as can be, same as x plus 2. So again, we're undoing the division. So to undo this, we'd have to multiply by x plus 5. To undo this, we'd have to multiply by x plus 2. So our lowest common denominator would use both those pieces, x plus 5 times x plus 2. So take the entire equation times that denominator. So again, remember, numerators get multiplied, denominators get multiplied. So here's what we'd have on the left-hand side. Here's what's on the right-hand side. At this point, again, we're looking to see what do they have in common we can divide out. X plus 5, x plus 2. So here on the left, we're left with 12 times x plus 2, which would be 12x plus 24. On the right, we're left with 4 times x plus 5, which would be 4x plus 20. Now it's a basic linear equation that we would undo to solve for x. So I could subtract 4x. Then I'd have to subtract 24. To get x by itself, divide by 8. And then always look to simplify your response. Negative 4/8 has a common factor of 4 that we could divide out, so we'd be left with negative 1/2. Again, you want to check and make sure that your denominators are defined, so substitute negative 1/2 back into the original equation. And simplify according to your order of operations. And make sure that they're the same value. Whether you put that into your calculator and get a decimal equivalent, or turn it into a fraction, you just want to make sure that it's balanced and defined. So here we want to solve our rational equation. Again, check, since they're fractions, is the denominators in their most basic components. So here, x minus 1, can't do any more factoring. 4, we could leave it as 4. We also know it comes from 2 times 2. So to undo the two divisions, we want to find that common denominator. So I definitely need the 4. I definitely need an x minus 1. So we're going to multiply the entire equation by both those pieces. Again, numerators get multiplied, denominators get multiplied. At this point, you're looking to see what common elements can you divide out from the numerator and the denominator. On the left, you could divide out the x minus 1s. On the right, we could divide out the 4s. So on the left, we're left with 4 times 5, which is 20. On the right, we're left with x times x minus 1, which would be x squared minus x. Now remember, you've got an x squared. That's a quadratic equation. In order to solve your quadratic equations, they must be equal to 0. So the quickest way to do that would be subtract 20. And at this point, you could use one of your 5 methods for solving your quadratics. Perhaps you could factor it, use the quadratic formula, complete the square, graph it. The only method you cannot use is undoing because it has the x squared and the x. Well, I would take a look at these values and ask myself first, is it factorable? So no greatest common factor other than 1. So are there two numbers you can multiply together to get negative 20 and add to get negative 1? I could use a negative 5 and a positive 4. So putting it in its factored form, we're going back to what we did in our previous units. Set each factor equal to 0 and solve for those values of x. Then make it true. So it looks like I could have x equal 5 or negative 4. We have to test each value of x into the original equation to make sure that it's defined and balanced. So let's do that. This side here on the left, I'm going to check my value of 5 for x. On the right, checking the value of negative 4. And I want to make sure that they're balanced. So here, I'm going to have 5 over 4, which is equal to 5 over 4. That's true. This one, negative 4 and negative 1, that's going to be a negative 5. So that would be 5 over negative 5, that's negative 1. Negative 4 over 4, that's negative 1. That's also true. So we have two possible answers, 5 or negative 4 for our equation. So rational equations could have one solution, two solutions. I wonder if it could have no solution as well. Again, that's why we're checking to make sure it's defined. Like we said in the beginning for our warm-up, if it doesn't check out and you get a 0 for that denominator, that would be a no solution. All right, one more rational equation to solve. Check those denominators, make sure they're in their most basic components, which they are. Now we've got to undo those divisions by finding that common denominator. Dividing by x, you have to undo that by multiplying by x. Dividing by x minus 6, you have to multiply by x minus 6. So the common denominator we need to multiply the entire equation by would be x times x minus 6. Again, numerators get multiplied together, denominators get multiplied together. Because we want to see, are there any common elements in the numerators and denominators for each piece of the equation that we could divide out. On the left-hand side, we could divide out the x's, so we're left with x minus 6 times x minus 3. On the right-hand side, we could divide out the x minus 6, we'd be left with x times x minus 3. So we know that if we multiply these two factors together, we would get x squared, negative 3x, negative 6x, 18, which would simplify to x squared minus 9x plus 18. On the right-hand side, we'd have x times x, which is x squared, x times negative 3, which is a negative 3x. So again, we've got some like terms to combine, so I could subtract x squared from each side. We'll be left with negative 9x plus 18 equals negative 3x. I could add a negative 9x to each side. So I have 18 equals 6x. And to get x by itself, we could divide by 6. So x should equal 3. Again, to make sure that this is truly the correct value for the equation, substitute it back into the original to make sure it's balanced, and we do not have a denominator that's undefined, a denominator of 0. So putting that back into the original equation, let's see what happens. So we have 0 divided by 3, that's a value of 0, and 0 divided by negative 3, that's a value of 0. Both of those are balanced. The 0 is in the numerator, not the denominator, so it's still defined. Therefore, x equals 3 is our solution.